speakers today. Shana ji, I mean, we have a mutual friend who went to the same college as Shana did, Kenyon College in Ohio. And when Shana was coming to do her research in Nepal many years ago, our mutual friend introduced the two of us. And one of the things we do is when we find out that anybody coming to Nepal from the US, we often request them to bring books. And Shana has been very generous in bringing not only books to our library, but also giving them as gifts. So this time also, she wrote to me several months ago. Actually, I've been writing to her, trying to persuade her to publish one of her papers in the journal that we edit together. And she hasn't quite done that yet.
It's on the list.
But then she wrote to say that, okay, mo Nepal aउँदैछु हैन, seminar गर्ने हो कि भनेर. So then we had several email exchanges that is now resulted in this collaborative presentation. Shana happens to be now a postdoc at the University of Pennsylvania, which is where I spent 8 years getting my PhD. So there's this kinds of coincidences. Now she got her PhD in political science from the University of Notre Dame. Her research involves themes of governance, environmental politics, disasters, and public goods with a particular focus in South Asia. She has published work on gender and post-earthquake rebuilding in Nepal, as well as on democracy and climate change. She'll speak about user perceptions and acceptance of earthquake early warning systems in Nepal. So we have kind of two papers session, right? And the second speaker is Trailokya Raj Bajgai, who is a PhD student in civil and environmental engineering at Duke University in the US. And his paper is Toward a Community-Led, High-Fidelity, Open Data, Low-Cost Air Quality Monitoring Network in Nepal. हाम्रो त्रैलोक्यजीको चाहिँ बोलाउने नाम चाहिँ, according to what Shana has told me, is Raj.
Yes.
So we call him Raj.
So many names.
Where in his PhD research at Duke, he's trying to focus on air pollution monitoring, low-cost PM 2.5 sensor networks, and applied AI for air pollution. He was educated in Nepal, China, and the United States, and he's worked with air pollution research teams in 10 countries across South and Central Asia. In May 2025, he delivered an official statement at the 10th United Nations Multi-Stakeholder Forum on Science, Technology, and Innovation for the Sustainable Development Goals, STI Forum at the UN headquarters in New York. So Shana, I basically told the two of them that they can speak for about 45 to 50 minutes. So it's up to them to distribute, the time in whatever they want. So Shana, Shana and Raj, it's all yours now.
Okay. Thank you for having me. Today I am presenting on a collaborative piece of work that I made kind of inspired, and because of the coordination we did in the Geo lab, that is a coordination between Duke and IOE here. So we were talking about this before. And this was created by Henry Gavin at Duke and Rachel Law, who is not here. And this really, it is two of the authors on this paper, so Sagar and Safo, as you can see right here, were undergrads when we did this. So Sagar was a student here at IOE, and he's now starting his, he just is finishing, I guess, his first semester at Michigan in engineering. And Safo is a third year now at Duke. And when we started, Rachel and I were actually grad students ourselves, but now we have both moved on to greener pastures. So yeah, it has been, I know there's a lot of students here, so if you have actually questions about the collaborative work and research, I can answer those as well. This paper it has been resubmitted after revisions to Earthquake Spectra, and received amazing, really helpful reviews there, so it has actually been different. So I know some of you have read this manuscript. The framing is a bit different now. But yeah, the larger discussion we would like to do today are things that kind of came out of this paper, which is really the need for multi-hazard focus and thinking about preparedness from multiple angles. So this paper is on earthquake early warning systems, which don't exist yet in Nepal, though there are some projects towards that. However, what really came out, especially from the interviews, was a focus on multiple ways to be prepared. All right, so I'm going to give you just a rundown, like a snapshot, and then I'll go through the paper. So the question of the paper is really, does the type of information about earthquake early warning systems, and so we abbreviate it as EEWS, acceptance of technology, of it as a technology for Nepali residents. And so what we really do is we separate out the information into limitations and technical information, and I'll speak more about that later. And then we test implications of what we think might happen using a survey experiment through Facebook advertisements, which we can talk about more. And then we follow that experiment with interviews, about 35 interviews to understand the results. And the answer is that there's no effect of information on the desire for implementation of the system. And we think that might be due to, as you all know, like really intense awareness of earthquakes and the damage that they can do in Nepal. However, there is an effect of the system's usefulness, depending on what kind of information it is. And the implications extend to both acceptance of the technology as the projects that are here kind of come to fruition, as well as continuation with the technology once those projects have been implemented. And so the roadmap, I'm going to present it as a paper. This is a quantitative heavy project, so please do ask questions if you have them, and I'm going to try to keep it quick so that we can move on to air pollution as well. So I will start with a brief background, the research question and the theoretical framework, as well as the hypotheses, the methods and data, and the results, and a larger discussion. Some notes on interdisciplinarity. I have found during this review process that some things that my discipline calls a theory, other disciplines call a model. So sometimes I will use model and theory interchangeably, but we can talk about that more in the Q&A if that comes up. So the background, which I don't really have to tell to this audience, is that there are a lot of earthquakes in Nepal. What you might not know is that there are no earthquake early warning systems, though there are actually some, not by our lab, but by others, some kind of ongoing projects and discussions, and there's a couple citations there. Supposedly there are also some sensors that were built right after the 2015 earthquake, though there's no actual program right now of pushing those out when an earthquake happens. However, earthquake early warning systems are not predictive, and that can be confusing for some people. They actually are kind of triggered when there's this first wave, as you can see in this photo, and then they send out the alert before the second wave, which will cause shaking, arrives. And so that means there can only be seconds to minutes before the shaking is felt, so between an alert and the shaking. And there also can be false negatives and false positives depending on where you are. There's a lot of research outside of Nepal, and we actually find this in our own survey too, that there's a lot of user preferences for mobile apps. And so the implications of this is that we really want to know how the information about the limitations and how earthquake warning systems actually work, how that affects how people might relate to these mobile apps if that were to come into fruition. So our research question, precisely put, is how does this information affect user acceptance of early earthquake warning systems as a technology in Nepal? And we split the information into the technical information so that there are two waves. When one wave hits, the trigger is, set off, and then the other wave brings the ground shaking that you might feel. And then the limitations, which is that really kind of highlighting that you might not feel, you might not get the alert if you're at the epicenter, or that there might be some false negatives or false positives. So this is really the same information, but we separate it into two kind of framing and two kind of ways of highlighting the information. And as we did this, since we were actually doing a survey as well, we also asked a lot of descriptive questions about how people relate to early warning systems, if they know about it, what kind of preferences they might have, etc. And this was really done so we could understand our sample, and then we could create some data which don't exist in Nepal of maybe some preferences of some residents. All right, so on to the theoretical framework, or the model that we were using. So there's this technology acceptance model, and really want to thank again the reviewers at Earthquake Spectra, because they really helped us kind of frame this in a very nice way. But this technology acceptance model kind of posits ways that different aspects about a system can encourage acceptance. And then once acceptance is done, there's even more models of what might encourage or discourage user continuance of that technology. So here the technology is actually the system itself, widely put, not just an app, but the app can also be part of it, and some researchers have looked at that in other countries. And so the thing that we focus on especially is transparency about the system in this project. And we do this because there can be a lack of understanding, this has been seen in other countries, about how earthquake early warning systems work, and about what to do when one gets that alert. And this builds on a lot of research globally, some really amazing research about early warning systems and about kind of the acceptance and continuance as well. And we look at particular outcomes. So we look at transparency. So does the transparency into the limitations and into the technical information about the system have an effect on the desire for implementation? We ask this specifically because there is not a system implemented in Nepal as far as we are aware. And so we think about that, if you were to think about it, if it were already implemented, you might almost think about that as in like trust. But here it's a little bit of a difference, like how much do Nepali residents want this system to be implemented? And later in the interviews, we look at that in coordination with maybe other types of preparedness. So building infrastructure, et cetera, et cetera. And then we also look at the effect of these types of informations on perceptions of usefulness. This is a really big factor in technology acceptance and technology continuance. Generally, it's thought that the less useful users think a technology is, the more they might not be inclined to accept it or continue that. We actually don't find that, so more on that later. And then we wanted to give just literally the survey users an opportunity to click a link to learn more. And so we took that opportunity to actually test that as well as an outcome. So we offered a link. If you want to hear more about this, here's a link to more about early warning systems for earthquakes. And then if they clicked yes, we counted that as yes, and then no as no. So as I've said, the main analysis is actually this survey experiment. It was an experiment randomizes different treatment arms. And so we had 3 different treatment arms and then 1 true control. And we can talk about more survey experiments, like why we did that in the Q&A, but it really kind of randomizes over other factors that can affect these outcomes for specific users. So by randomizing, we kind of get an average for all of the people in our sample. And again, those outcomes, as I discussed before, the first 2 are on a 5-point scale, following a lot of literature. So for example, desire to be implemented, don't want that implemented at all. 3 is no real, opinion. And then 5 is really do want that implemented. Perceptions of usefulness also, and then the interest in learning more, it's that binary, do you want this link or not? And so just to talk a little bit more about the survey experiment, every respondent was shown either a control, which we created as just information about earthquakes in Nepal in general. We assume that all people who are going to take that know that, and so that's kind of a control that should have no effect in terms of the actual information that we're studying. The first treatment was technical information, the second was the limitations, and the third was both combined. We did try to make them as similar in length as possible, though they were a little bit different. And the reason we did both combined is because we assumed that there might be that might behave differently than just one on its own, and then kind of like looking at that statistically. And then we hypothesized that the technical information would actually increase all of the outcomes. So technical information would increase desire for implementation, opinions on usefulness, and interest in learning more. And we thought this because it would be more transparency into the system. People would understand what is going on, and therefore they would kind of trust it more, and therefore lead to positive outcomes on all of these. For the limitations, we thought it would be negative for desire for implementation and opinions on its usefulness, though we did assume that people would be interested in learning more here. And then we thought the combined, we were actually wrong about this, but we hypothesized that the combined, that information about how the system works would actually override the limitations. It's actually opposite. We found in the interviews and the survey that information on the limitations actually overrode the technical information. So people almost always were like kind of focused on that when they heard it. All right, and there are some limitations. It is a non-representative sample. We can talk about that later. And then to understand our results, we did some interviews afterwards, which were semi-structured. They were deductive, so we did it based on what we found in the experiment, and they were short and very kind of targeted. All right, so the data. I said that this sample was non-representative, which we would expect via a Facebook survey for many reasons. It was really not representative, and I was actually very disappointed to see that. We can talk more about that later, because I was kind of hoping that there would be a way to get more reach in Nepal, just with not an in-person, data collection strategy. Anyway, the thing is, I guess now there are a lot of bots, so even over the last 6 months, you can't really trust online experiments. There's just a new paper that came out that I can share with you if you'd like. So maybe we just got in right before that. Nonetheless, we still think that there's a lot that can come through this sample and this survey, but it must be noted that this is not, the opinions here are not the opinions for all Nepalis across the country. The interview was a little bit larger in scope because we were able to target. However, our interviewer was the second author, Sagar. That might have some, reason why we maybe got less women who were able, who consented into it. But yeah. All right, so the results, I have about 3 minutes left. Just to give a quick background about the sample, because this is interesting compared to other samples in other countries. Granted, some people who might be anxious about earthquakes might have had selected into our sample. That being said, in our sample, we found a very high background experience with earthquakes. 71% had felt strong shaking. That might actually not be a surprise to anybody in this room. I think maybe we've all felt strong shaking. But that compared to other surveys that have been published in countries like New Zealand and I believe Switzerland, that was something like under 10%, quite small. There was also a high earthquake anxiety, so about 60% said they were very worried about earthquakes. And there was a low knowledge of earthquake early warning systems, even among this highly educated sample. So our sample was, I think the majority was university, 30% was university educated, I believe. And about the biggest one about this was 30% had heard about early earthquake warning systems, but did not know much about it. Following other surveys, we did find a strong preference for phone apps. So I think that especially with the technology acceptance, has implications for future research and also future projects that are trying to implement this. All right, and so what we found is we found null results. So that means there was no difference in the treatment and the control for the technical information over anything. So the technical information did not change people's opinions on their desire for implementation, on their opinion about the system's usefulness, or about interest in learning more. That did nothing if we showed that compared to the control. The limitations, however, reduced people's opinions on the system's usefulness, and it increased their interest to learn more. So people who had seen the limitations were more likely to say, like, yes, please, give me more information. The combined information decreased people's systems of usefulness. So what we see here is really that the information about the limitations did overshadow information about how the system technically works, at least for opinions on usefulness, not for the desire for implementation. And I think that's an important thing to note coming up. What's interesting about the interest is that based on the survey results, it seems like the interest was really driven on like the why. Like, these are the limitations, but like, let me really understand why. And so then when there was that combined information, people were no longer like, I'm not gonna click that anymore. We did give all survey respondents the combined information at the end, by the way. So this is also kind of like a, public communication as well. And so nobody was left with just one treatment or the other. Everybody was left with combined information. If you'll remember, we had hypothesized this. So there were, a bunch there that were null, there was none. It was true that the limitations did decrease opinions of the usefulness, but the combined information did not increase, so that's contrary to what we had thought. So there was a negative effect there. And these are the results, which y'all can see if you would like, and these are how they look, via graph. So this is on the desire to implement. The gray doesn't come across there very well, but these are all hovering around 0. The bottom two here are above 0, and so those are the ones that had a negative effect. And here, the top and the bottom, so this is the interest in learning more, those were null, so they're about on 0, whereas the limitations increment on the limitations pushed that over 0 a little bit, so more people were interested in learning more who got that one. All right, and so the takeaway was really that there's not, like, at least from the survey, people want the system to be implemented. And as it came through in the interviews, it's because people are just concerned and that they think that there should be a lot of ways to prepare for earthquakes. So just to go forward to one of these quotes from the interviews, this person said, "I think it is better to have the system than to not have it. We can have conversations about limitations after we have such a system." And so, contrary to some past research, some theories that are looking at usefulness as tied to implementation or trust, in the Nepal case, we just did not find that. Everybody wanted it. And the limitations really overshadowed the technical information for the usefulness. But the implications of that going forward is that might be a good thing. Because we had a lot of interviewees who were saying that, once I know about the limitations, or once I know about this technical information together, I know that when the alert comes, the first wave has been detected and I need to do something for the second wave right then. So as opposed to thinking of decreased opinions on usefulness as a bad thing, as we had originally thought, I think we need to rethink this as some type of like preparedness measure, like how to actually interpret this. Finally, the interest was interesting. People are actually interested in how these work. We also found that during the interviews, they were able to talk to Sagar, who is a recent engineering graduate, and people were really going back and forth with him asking about it. And there might be some implications there about like how to communicate these types of things. So maybe an interactive type of modality. All right, I'm done. So I'm not going to go through all the really cool quotes that I have. I'm sorry. But the things that we really found are that, let me do a not heavy, I'll just do this. When people heard about this information in the interviews, it seemed to reposition a potential earthquake early warning system in combination with other types of preparedness practices. And so I think what we find is that this kind of information might not really affect acceptance of the technology, but in fact, telling people about the limitations might help them prepare in multiple ways, if that makes any sense. And then we also found, which did not come from the survey experiment, that a lot of people were interested in earthquakes, but not just earthquakes. We asked a question about how important is this preparedness to other types of things, and people had a variety of opinions. Some people are saying, I think floods and landslides, are not so important, but pollution is encountered daily. Now this is in Kathmandu, therefore we need to do that. We had other people saying that no, earthquakes are really important because they cause such great losses. Therefore, we need to have all of them. We need to have pollution preparation. We need to have earthquakes. We need to have landslides. We need to have flood preparation. And so this is just all to say that people are positioning themselves as wanting to be prepared and as wanting communication. And let me just do one more thing. Sorry, Raj. I'm just at about 20 minutes, but there's this. We had one respondent, and I think it's worth highlighting, even though it's a really big chunk of text there, sorry. And this question was, I think it was, what else do you want us to know, or something like this, or what do you think is important? And he said, first of all, and he was very resolute, answers to questions like, when will earthquakes occur, and what should we do in the event of an earthquake should be clear. Before the 2015 Gorkha earthquake, we were told to drop, hold, and cover if we were inside buildings. But some people would go outside easily from their buildings and also did drop, cover, and hold, and some of them died. So we don't know if this is true, but this is what he had perceived and experienced. So first of all, we need information about what to do when a big earthquake strikes and what to do when a small earthquake strikes. So he really kind of even circumvented our question about what if there was an early warning system. And this was also, other interviewees had this as well. And they really said, no, we need more communication and education about earthquakes in general. There was a little post on LinkedIn yesterday too, that somebody was actually saying, I think they're a UK-based Nepali researcher, saying that this is actually really needed, even in meetings like this. Yeah, and this goes towards other work that is being done. Shubedi and Hetani, who has this paper about like the need for communication and education in Nepal as well. Thank you very much. Let's move on to air pollution.
So I'm going to talk about low-cost sensor networks, air quality sensor networks and air quality monitoring in general, and what's the status of low-cost sensor networks in Nepal currently, and what were the lessons we have learned so far, and what we are planning. So, and I'm Trilok Kirazbaskai, I also go by Raz, he's the student at Tube. So before I start my research, I just want to tell that this knowledge is synthesis of like things I learned through my experience in my research work, field work, and then the information shared by our research partners, my lab mates, and by my mentors. During simplifications, some nuances might be lost. We can discuss more on that during Q&A, or like you can always reach out to me via email.
I think he just doesn't like your computer.
Yeah. So like email it or should it be okay?
Continue
Some glitch. Us. Nobody's. So the problem is mostly straightforward. Like we all know air pollution is bad. I mean, it is nothing. So we have this news coming around, like some suggesting, millions of people are dying because of air pollution. Or just a new report, I think in June, World Bank published a report saying air pollution is #1 health risk factor for Nepal. Or this, right? So it's the most, in average, about 3.3 years is taken off from Nepalese, an average Nepalese life expectancy, or like 6% of Nepalese GDP, the loss of 6% of Nepal's GDP, just air quality related issues based on the World Bank's report. So, but how bad is the current air quality in Nepal? We know by looking around and be like, oh, the air is really bad. But what's the status of monitoring here? Yay.
Perfect.
Okay. So oh, I got lost in my chain of thought, but come back. So for that we'll need data. We need very reliable data, right? And for that we need sensors and networks of those sensors. What's the current status? Before we dive into it, let me just quickly touch base on the sensors, the kind of sensor we use for measuring air pollution, or in particular, particulate matter, which is the most, I think, dangerous, quote unquote, and most studied, and currently the most popular. The AQI is usually measured using PM2.5, particulate matter 2.5. So so the state of the art is to just take a filter paper, like a very precise measurement of the weight you acquire by just letting that filter paper pass, let the air pass through that filter paper. It's called federal reference method, very technical, very extensive, and you get one data point every 24 hours. The another one is called federal equivalent method. You use beta rays, it's called beta band, and for that you pass through a ton of electrons, and then that is how you do some fancy calculation, and then this is precise, but both of these sensors cost tens of thousands of dollars, a ton of technical expertise to run. The current innovation now is instead of using, say, a beta array, or like instead of like measuring this filter papers, you can just use the property of laser lights, and we have improved significantly on the laser light technology. And then using that, now we have something called the low cost sensors, and then that basically uses properties of laser light to estimate like how many particles are there in the air, and they are fairly precise. Like given the price point, it drops down the price point from tens of thousands of dollars to a few $100s. And yeah, again, the key is you can't fix what you can't measure, and then monitoring is key. And then let's like quickly see what's the current status of monitoring in Nepal. For the BAM, which is Federal Equivalence Method, I think the Nepal government's like environmental department has several of these sensors all around Nepal. But as you can see in that image, like data is mostly missing. The sensors are not usually up, and then there are also very few around like spread throughout Nepal, and we don't actually like know. It's nowhere near what we need. And then since the emergence of this low cost technology, several new low cost networks are like coming up. Like this is a screenshot of a TSI based low cost sensor network, Purple Air. There is one employed by Kathmandu municipality now with I think Clarity, and then this is I think IQ here. So there are few. And then this is one of the network we deployed previously with Central Department of Environmental Sciences at TU. We deployed around 70 low-cost sensor network. I think it's the largest network we ever had in Nepal for air quality monitoring. Still, you can see it's too far too less dense. We need slightly more coverage. And then it was in Kathmandu. There are like some like people working like based on Kathmandu too. There are some initiative based in Nepal. There was this small new company called Biodrishti, and then they are also like trying to produce low cost sensor indigenously here. And then the current challenge is these networks are like too fragmented. Like some of these are project based, a lot of these are black box. Like they usually don't share the data. We don't have like proper dashboard that are reliable. So there are things like IQVIA that would say, oh, we have like this much AQI in Kathmandu. But how did they measure the data? This low cost sensor are very precise, but usually not very accurate. So for that, we need to have this process called calibration, harmonization. Like, we need to co-locate it with like a really expensive monitor and then see, oh, how much they drift, all these different processes. And most of the time, these QA/QC protocols, these calibration protocols are not followed. So we cannot say these are high fidelity network. We cannot be reliable, like we cannot reliably use this data. And then they are often very black box, and most of this project does not even want to like cross collaborate, which is also like a big problem. And equally important is network designs matter, right? Like if we want to know like how much pollution is traveling from say Tarai up to Himalaya, we need like transect of those network, right? We need those network around those elevation gradient for anything. Like if you want to understand, oh, like there is this external like outdoor air pollution, how much of that gets into our house? So we probably need an indoor-outdoor pair for that. So whenever we deploy a network, we need to really think about network design. And from what we have seen, what we have heard in the field, most of the time it's like find a spot where we can. And then this also leads to very interesting problem and challenges using this data. So a lot of the times, like systematic setting criteria is missing in these projects and in this network. Like they are not that representative. Most of them are like located in Kathmandu. When I was back in my hometown just a week ago, people are telling, oh, the air quality in Kathmandu is bad because it's a big city and a lot of people. And here is a lot of green field and a lot of trees, and our air quality must be good. And then I could just look at it, and the visibility was about 1.5 to 2 kilometers, and I'm like, air quality must be pretty bad. And then I put 2 sensors at my home, and for entirety of last week, my home was consistently like twice or thrice as much polluted as Kathmandu, and I was like, I knew it, but yeah. And then we can also, the new research is showing that we can use additional information like geospatial data, satellite-based data to make this network design Yeah, for this network designs, we can use meteorological patterns, we can use even additional data like population density, where the factories are located, and so many different components for that. And then the lessons we learned from working in several different countries, and our like largest deployment of like 70 sensors in Nepal is that early design phase is critical, and a lot of the time people usually skip over it. This is like hearsay, so you cannot like quote me on that. But when I was talking with people and stakeholders in Nepal, currently they were like, yeah, like somebody sent like giving a sensor for free, and we're just like putting it wherever we can. Most of this time, this early critical phase, early design phase is not critically done. QA/QC is not properly done, and all these different things. And one of the main problem we have faced in Nepal is we don't have local knowledge base, and it's not super technical. Like somebody in third or fourth year of their engineering, or like third or fourth year of like decent technical knowledge can like calibrate these sensors and harmonize and co-locate and just do basic data analytics. But even that was a big challenge for us when we had this larger network deployed. So we want to probably have one local knowledge base in some institution which can like ease this process. And then our aim for future is to have a community-led, like where this is not just based on one project. The ownership, we need to think about ways to have it within the community. Like the sensors, it belongs to community somehow. And then we need to make it very high fidelity. We had a lot of knowledge in our lab where I work for, like based on our work in like so many different countries. We really need to make our network high fidelity. We need to make it open data. That has been the biggest problem right now. Even government data. One of my friends was telling me they went to ask the government data, and they were not giving the raw data. Not hourly data. They were just aggregating daily, and then so many things are lost in the process, and it's very, very difficult. And then if you don't have reliable data, how can we start asking even more critical questions regarding air pollution? Like even all the econometrics, like for example, the World Bank report, when I read through it, it's not on actual sensor reading this data much. They actually create a model based on like limited sensor, and then they're extrapolating things. So we don't actually know the ground truth much. We also, the low cost thing, I had like several asterisks there because it seems low cost relative to this like sensor. If you have like 100 of these sensors that cost few $100 on top of that, the cloud subscription fees and everything, it's quite a significant cost. Not too significant, but still substantial. And local knowledge base. We want a place where all this information is stored so that whenever we have a new project, we don't have to start from scratch. And the main thing, like, because I'm in this scouting phase right now for a new network node, like the thing I want your input on is what you are most interested about air quality things. Like I just want to like gauge interest in air quality and what should we additionally include in the new network? What kind of questions are you interested in? And then we are now in the most fun part of this entire talk, the question and like Q&A session. Thank you.
You're so much better than me on time. I think we can just open in questions.
Yeah.
Questions can be in English or Nepali.
Yeah. Should I like put this question and thing slide? Yeah, maybe.
Thank you so much, Shana, for your presentation. I have very simple questions.
Yeah.
But I was lost when you were doing presentation, and the question is, since your findings on public perception and acceptance of earthquake early warning system contribute to broader debates or tradition within political science, such as public governance, public trust, public adaptation. I was wondering how your current research contribute to the tradition of political science.
Yeah, good question. This is not a political science paper.
Okay.
This is an interdisciplinary paper with engineers because I care about this subject, and so I really try to contribute as much as possible. In the survey, I did have one survey experiment which I was very interested in terms of governance and political science, which is who do people trust? So I think I randomized government actor, private actor, and then maybe a combination. However, our N, I wanted around 2,000. We got around like 550, something like this. So that one is not going to have enough power. But yeah, in terms of what I am interested, so like I should have said, my own research is actually much more political science, much more social science based, comparing the reconstruction processes of communities in Kathmandu Valley, specifically actually the cities, so Kathmandu, Patan, and Bhaktapur. This is something that just comes out of mentoring about these. It came because I had a personal interest also in how people are preparing when they're rebuilding their homes, the codes, and then just by virtue of mentoring students at IOE on research, this really kind of came out of from very kind of ground place. And I have knowledge in how to do survey experiments and surveys, and so I really just led the project, honestly. I really think that there are a lot of governance-based implications of this kind of thing, not only in terms of ownership, as Raj was talking about, but in terms of who people trust and what happens when these kinds of don't act as they should, and who people blame when these kinds of technologies maybe don't work the best. Yeah, so that is all to say this is a very interdisciplinary project, which has been very interesting actually in the publication process. So you get reviewers from all over, and terminology may be different. But yeah, does that answer your question? Did you have any? Yeah.
Okay, I have one. Could you talk a bit more about the technology acceptance model?
Yeah, I
What
think.
is it and how did you use it?
Oh God, see, I knew I should have reread the manuscript last night. Yeah, technology acceptance model, and it's like its brother, the technology continuance. Is something that people are starting to look to in early earthquake warning systems, especially like Tan et al. They have quite a few papers on this in New Zealand, I believe, but don't quote me on that. And it comes from technology more generally put beyond earthquake early warning systems. I think the seminal paper that I read was actually from like '85 on technology acceptance, and that's more of like any technology. Even think about like AI. Or I don't know, medical apps on your phone, or I don't know what the technology is. Maybe computers in the 80s, honestly. And it is what things increase people's trust of a technology, and that's why the usefulness comes in, because if people think a technology is not useful, if I don't think a computer is useful, I'm not going to use it, for example. And so that's why there was this, there's this idea that if people don't think an early earthquake warning app, if it is something to be downloaded, if it's not something that's just coming in, if they don't think it's useful, we were thinking they might not accept it, which is why we were really looking at that. I think the bigger implications are actually in continuance once the technology has also started. And so it's how much do people trust this, and that's where the transparency comes in. How much do they know about this? How much do they trust it? Previous experience. So like, for example, there's an earthquake recently in Mexico, I don't know, in the past 2 decades, where the sirens actually came after, the sirens actually came after the ground shaking was felt. And so there's some really wonderful work, interview-based work out of that, showing how people really, that's going to affect their trust. And in that case, maybe, I don't know what continuance means in that sense because they're sirens, but anyway, their relationship to the technology. So the technology acceptance is really kind of like how people buy in to technology, and here, how do people buy in to this early earthquake warning system if it were to come to fruition? And if, an app needs to be downloaded, how they would, will they download this? Will they look at it, etc. Does that answer all of your questions? There are very specific models. I can send you all the papers. It's very interesting and very great. Yeah, I was saying with the review, before we had really framed our paper in terms of we need to know what's going on in Nepal, because that's how we came to this question. And we only had a little bit of this model kind of in the framing. And now framing it in this way, it's amazing how much better kind of these insights come out. Yeah, just for you as a student to talk about the process.
So Raj, you began your presentation by referring to something that I see a lot of people talking these days, which is saying that air pollution cuts out 3 or 3.5 years of people's expectancy. How do they actually calculate that?
I think it's based on global burden of disease. So like they calculate, I think it's more like associative like risk factor, and I'm not like super like on those domain of technicality, and I trust the global burden of disease, which is the standards globally. So most of these calculations are based on the global burden of disease and their DALY value. I think disability adjusted life something. Yeah.
And so, given that you are a civil and environmental engineering PhD student,
Yes.
what does community mean for you?
Hey.
It's a word that gets thrown around, and
Yes.
as a historian, I can be quite specific about what it might mean to me and as other practitioners in the room. But for an engineer, what's a community?
Yes, I'm technically a semi-engineer because I jumped from data science, and then yeah. But I think for me it means whichever location we are using, like institutes and then organization or even individual based on that location, having both the ownership, maintenance, and all those things, particularly on the sense of network. If it is community owned, it's owned locally, and then ideally not by just individual but an institution that is ideally not for profit, like that is trusted by the community too, something like that.
I mean, just a suggestion. You might want to be more specific than that, because the way you've just described what you think,
Yes.
what you understand as a community, that community probably doesn't exist,
Yeah,
if it ever did.
yeah, true.
Also, Sweta.
So, I'll try to speak, but I was in Amsterdam. Well, is it networks are fragmented, network doesn't matter भन्नुभयो होइन अनि विभिन्न ठाउँमा चाहिँ नेटवर्कको चाहिन्छ भन्नुभयो र मैले तपाईँको कन्टेक्स्टमा नेटवर्क भनेको तपाईँको पेपरमा चाहिँ मैले नेटवर्क भनेको के भन्नुभएको नि बुझिनँ सो त्यो चाहिँ एकदम एउटा बिगिनिङमा एउटा फोटो देखाउनु भएको थियो
हजुर
त्यसको आधारमा अलिकति नेटवर्क के हो भनेर बुझाइदिनुहोस् न
हुन्छ सो अब हामीले जस्तै कुनै पनि एउटा एयर पोल्युसन
Did you get my
Oh, yes.
सो जस्तै अब हामीले एयर पोल्युसन कहीँ नापिरहेछौँ हो जस्तै पहिला यो पुरै विधि एकदमै महँगो थियो एकदमै महँगो भन्नाले त्यो फिल्टर पेपरमा नाप्नुपर्ने एकदम टेक्निकल काम भएको भएर एकदम लिमिटेड अमाउन्टमा जतिखेर यो युएसमा यो रेगुलेटरी फ्रेमवर्कहरू बन्यो त्यतिखेर चाहिँ हामी कुनै पनि एउटा पोइन्टमा एउटा ठाउँमा चाहिँ त्यो ठ्याक्कै नाप्छौँ तर अहिले हामी जति चाहिँ यो बढी नापिरहेछौँ धेरै ठाउँमा एउटै ठाउँमा पनि 500 मिटरको अन्तरालमा पनि एयर क्वालिटीमा चाहिँ चेन्ज आउन सक्छ एक ठाउँको रेटिङ जस्तै यहीँनिर कसैले बेसरी आगो जलाइदिएको छ अनि त्यो चाहिँ मिक्स भएर सायदै 500 मिटरको रेडियसमा चाहिँ झ्याप्पै पोल्युसन बढी देखिन सक्छ अनि त्योभन्दा अलि पर अलि कम देखिन सक्छ अहिले चाहिँ अब त्यसैले चाहिँ पहिला भनौँ 2010 मा यो पुरै काठमाडौँ सहरमा 3वटा ठाउँ हुन्थ्यो अनि 3वटा ठाउँमा चाहिँ अब 3-4वटा ठाउँमा भएको त्यो सेन्सरहरू हेरेर चाहिँ काठमाडौँको कति होला एक्स्ट्रापोलेट गरिरहेको थियौँ तर अब चाहिँ के पोसिबल छ भनेपछि त्योभन्दा नि धेरै सानो सानो रेजोल्युसनमा धेरैवटा सेन्सरहरू राख्ने अनि तिनीहरूको जो कलेक्सन छ त्यो कलेक्सनबाट चाहिँ हामी अझ बढी सोर्टिङ हुन सक्छौँ कि काठमाडौँको यो पुरै भएको एभरेज पोल्युसनको लेभल कस्तो होला र कुनै पनि लोकल अथवा हाइपर लोकल अनि त्यो कुराहरू चाहिँ हामीले धेरैवटा डेटा पोइन्टहरू अथवा धेरैवटा सेन्सर भयो भने त्यसमा चाहिँ स्ट्याटिस्टिकल टुलहरू युज गरेर चाहिँ बढी सोर्टिङ हुन सक्छौँ कस्तो रहेछ काठमाडौँको यथार्थ चाहिँ विल गेट मोर क्लोजर टु रियालिटी हुन्छ नि एक्ज्याक्ट हामीले कहिले मेजर गर्न सक्दैन किनभने यो कन्टिन्युअस फिल्ड हो अनि पोल्युसनको फिल्ड कन्टिन्युअस हुन्छ तर त्यसमा चाहिँ झन् बढी सर्टेनिटी आउने हो 3टा पोइन्ट
सेन्सरहरूको लाइन नै नेटवर्क
सेन्सरहरूको कलेक्सन भयो भने नेटवर्क हो मल्टिपल सेन्सर अरेन्ज्ड इन अ सर्टेन वे इट विल मेक अ नेटवर्क
Yeah, I had a question for Shona.
Shana.
Sorry.
Both are good.
so nice
And I want to go back to governance and your political science background. Because of the rush of you had to rush this whole thing, presentation.
That's my bad, sorry.
No.
No, it really is mine.
Why are you pointing?
She's blaming you. No, but I asked that watch to be here, so it really is mine.
So you had said something about it didn't matter if people were the technology acceptance, right? And one of the findings surprised you.
Yeah, so it's that and I should have included another graph there, maybe. I had a hard time knowing what to include in this presentation. So the average on a scale of 5 for the desire to implement for the people who got the control, so that was just nothing, it was just information, was about like 4.5. So almost everybody who got the control thought the system should be implemented. And the average for those who got the technical information, about the same. The average for those who got the limitations, about the same. Doesn't matter what information people were given, they wanted the system to be implemented.
Right, and this finding you said surprised you.
Yeah, it didn't follow the past literature. I mean, like, I guess it makes sense now that I think about it, like, duh. But like, you know, we thought maybe, or I was thinking actually, so I'm the one who made this part, I won't put it on my co-authors. I thought that people, not that this was tested in the study, but I thought that people would reprioritize and say, we don't need to spend money on that system, we need to spend money on something else. So we didn't test that in the survey, but that's what I thought people would go through people's head. So like, we don't need to implement the system with these limitations, or the technical information is really interesting, we do need to implement the system. I thought that the information would kind of sway people one or the other, but in fact, we didn't see that. There might be a slight effect that we just don't have power to see because we only have about 500 observations, but if there is, it's what is called a ceiling effect. That means everybody really wanted it to be kind of highly implemented, so we can't see any variation there.
Well, the reason I wanted your clarification on this was because from a governance standpoint, right, this is so obvious.
Yeah.
Because Nepali citizens have never had a government that works for them.
Yeah,
And so they're so desperate
yeah,
to get any help.
yeah.
So to me, it wasn't a surprise. So I wanted to know why
Yeah.
you would be surprised.
Yeah, it's because of my training in which literature comes first. Honestly, no, I mean, I think it's a good way to do that as well. But also something, and I didn't have this in the slides, but there was a very interesting quote I'm remembering now. And there was, this was a woman, I believe in Lalipur, I can't remember exactly, and she said that the reason to have a system like this is, the reason she actually explicitly said that the government should do it is because the government can't give money out to everybody to make their houses safer, but the government can do a system like this and it would reach more people. And I thought in terms of governance, that really, really stood out to me.
And that whole thing about, well, Nepalis are not really concerned about the earthquake, but they're concerned about floods and blah, blah. I mean, Nepalis are seasonally hammered by everything, right?
Yeah,
So
yeah.
again, in that context, it is no surprise
Yeah,
that it
yeah,
wouldn't just be the earthquake, right?
Yeah, exactly, yeah.
Earthquake amnesia to some extent exists, right? But everyone is
Yeah.
well aware because we've got tremors all the time. We get the
Yeah,
suns out,
absolutely, yeah.
fires
Yeah, and I wouldn't,
getting it.
I didn't mean to say that nobody was interested in the earthquake. What I meant to say is that like, there was a wide variety. We can't say with the sample that we had. Some people thought like, no, the earthquake is the most important because it kills the most people. Some people thought air pollution is the most important because I have it every day. But nobody, I was with that interview question. I actually didn't hear the interviews because in our IRB, only Sagar had the recordings and then he translated and deleted. But what I thought when we were writing that question was that people might reprioritize certain things. Like, yeah, this one is more of a greater priority or this is more of a greater priority. And people did do that, but it was so, the variation was so massive that what really I think stuck out was this multi-hazard, as well as with earthquakes itself, oh man, there's just some very interesting interview cases in which people are like, oh no, this is really disappointing, but we still need it. You know what I mean? Nobody was like, oh, I know one person out of 35 said we don't need this at all because the limitations are just too much. Everybody else was like, no, we need that, and we need better education, and we need better infrastructure. You know what I mean? They're like, we need it all. Yeah.
I wanted to know more about who were your participants, more specifically, what was the selection process?
Yeah, qualitative or quantitative? The survey, the qualitative.
Yes,
It was
I got it.
convenient, super convenient. So we can't make inferences to larger populations, but we did see a lot of patterns, with both of these samples. So Sagar literally just went and walked around in the main kind of squares here. So Kathmandu, Patan, and then Pokhara actually, and then just asked people. We had American IRB. We have a consent form. Here's what this is about. Here, kind of about what we're studying. Here's how long it will take. Can we record you for translation? blah, blah, blah. And we did give out a phone recharge card of about maybe 200 rupees. I forget whether or not we finished. Yeah, so incredibly convenient. They were not theory buildings, so they're very short. I think the median was just about 14 minutes. The biggest one I think was 25 or 30 minutes. Smallest actually was like 8, because if people really didn't know anything, mostly the interview was just them asking questions. Yeah, and so we stopped at 35. We originally, I was kind of hoping to do almost like 50, but we were really just seeing a saturation. And so I just thought, not waste people's time. But I do think like a qualitative study that is, really kind of theory building around these things would be definitely worth doing. Does that answer your question?
Yes, sir.
Actually, my question was similar to yours. The reason I wanted to ask that question was because I didn't knew this kind of system exists,
Yeah.
or especially in Nepal, people are used to this kind of system to detect the earthquake thing. And you also mentioned in your presentation that this system will, if I understood correctly, this system will only detect the earthquake for like 30 seconds to a few minutes. So,
That's right.
if that would be the case, even a group of people to whom I belong, of my age, I would not download that system in my.
See, this is the acceptance, the earthquake acceptance. Yeah. You are actually what we expected you to
download
be.
it. I would just go about my way once the world starts shaking.
Yeah.
So why would I, if the system only detects just right before the 30 seconds.
Why would I
about
do
the
this?
earthquake
Yeah.
is about to come. So why would I download it?
Yeah.
So yeah, and you also mentioned after mentioning the limitations, people started telling that this system is not required. So is it?
No, we expected to see more of you, and we did not. So that's the interesting thing. Yeah. The opinions on something's usefulness is generally negatively associated, so it generally brings down people's acceptance of the technology and people's continuance of it. So we actually found a bit of the opposite, that people still thought that it was important. And the reason why we thought that, and this was after some thought, is that it was interesting in the interviews, you could really see people waffling, like, oh, that's not a lot of minutes, you know what I mean? And then they would be, but it could help some people. And so you kind of saw a lot of this thing, and so you saw it kind of repositioning itself as like one thing that could help. We didn't tell respondents this, and I should say in the interviews what we did is we asked about what they knew about earthquake early warning, so we got that background, and then we also told them the limitations or the technical information as we did in the survey, but then we engaged more with them about that, so we asked them what their responses was to that. We also noted surprise, so we coded surprise and things like these. We coded interest in terms of engaging, etc. But yeah, so you are exactly correct to bring that out, and that's actually what we expected, with the model, and we expected that to be a bit mitigated by the technical information, because we thought that it would tell people that the system was not failing. That's actually how the system works, and that's the only way the system works right now. So we thought the technical information would kind of like mitigate that, and it did not. People were so surprised by the limitations. That being said, again, our samples are not representative of, maybe there are more people who would not actually accept this. Maybe the people we just happened to talk to who consented in are particularly worried about earthquakes. So maybe those people will always download an app, no matter if they get seconds or minutes. Does that make any sense?
Yeah, so can you also tell a bit more about what were the limitations that you mentioned?
Yeah, the limitations are just the seconds to minutes. It was, I can, if you give me your email address, I can actually send you what the wordings, I should have included the wordings. But it's pretty much the same basic information in all treatment arms of the 3 treatments, except for we kind of highlighted the minutes to seconds. In the limitations one, which is totally correct information. There are only limitations because, that you might be limited by what you can do. they're not limitations in terms of the system failing, it's just how the system works. The sensors, you know, they cannot predict an earthquake. They just, when the earthquake has, you know, hit, it detects those first waves, and then it can send a signal before the second waves. That's just actually like technically how it works. So the limitations highlighted that seconds to minutes. And I think it might have also highlighted that at the epicenter, you know, it's really uncertain whether people will get enough or not. Yeah, you know all about this one, maybe.
Yes.
Yeah, this was more for the engineers in the paper to construct the treatments. Yeah, but like, as I said, like, these limitations are also important. So the takeaway isn't to not tell people limitations. We have to tell people the limitations, right? Because in the interviews, like one person thought that we could predict earthquakes like 3 days ahead of time. Like if they had gotten that alert and then thought that they had 3 days, you know, that's gonna be a problem. Other people, it was a little bit more like 30 minutes or something like that. So if this system is implemented, a really, you know, a communication effort is going to have to be surrounded, you know, for behavior. Does that answer your question? Did you have something to say?
Yes, and particularly this system also need other parallel system in place to really reap the benefit, right? So if our grid systems are automated and we have this alert 30 seconds before, if you shut down the grid power, it's going to save like, you know, a lot of other stuff. Or if the emergency power backup system within hospitals are kicked in, and Japan is the like a really big pioneer in this early warning technology systems. So basically how this works are they are going to they would know the fault lines in their context. For us, it's the Himalayas. They are going to put a series of like sensor nodes, and they will have multiple different readings coming out. And there are these two kind of waves, S waves and P waves. And then the P waves, whenever the earthquake happens, there is this the two series of waves travel. And one of these waves is really fast, but not that powerful in magnitude. And this the really slightly slower but very powerful wave is coming. Right? For example, if you remember the earthquake from 2015, we like saw a time like, oh, it started at that time, but in Kanchanpur it had like hit 2 minutes later, right? So this second massive wave of energy is going to come like depending on the location and distance and so many different factors, from few seconds to a few minutes late. And then what these systems are doing is they are detecting this like very big P wave, which is very tiny. And based on those P waves, they are predicting, oh, the coming S wave is going to be this massive, with this magnitude, with this much damage, and are like enabling this automated emergency protocol, are like warning all these people in like, for example, in US, we have this Amber Alert system. So we don't even need an app. Like your phone would start like shouting like crazy, regardless if you have installed app or
That's
not.
not for the earthquake,
Yeah.
that's for missing children.
Missing children, but again, like there are these other technologies in places that we can enable, but for that we need all the systems in place. In case of Kathmandu, which is a long way ahead.
And I will say that these kinds of systems also really depend on education, because there is research that shows getting this alert can actually help people psychologically prepare. So even if it's just 30 seconds to a minute, there is research showing that it does help people. But there's so much confusion over what to do in Nepal, as we saw, that I don't, you know, this has to be paired with kind of like good public education and communication over what to do. Yeah, we actually had a reviewer ask, what should you do in Nepal? And I was like, well, there's not a national policy, but INSET has the drop, cover, and then hold on. But as you can see, even from one of our interviews, there's some uncertainty around that.
You app चाहिँ कसले बनाएको त?
App बनेको छैन. We are just like gauging about that thing.
There is a very interesting, and I can send you, a person named Kuna et al. We have not discussed, unfortunately, but they are implemented with a European university, I think the University of Oregon or Oregon State, and then one other thing, an open source set of sensors somewhere just in a very small place in Nepal, and they've been kind of testing it for several years. And that should be coming to fruition. So yeah, honestly, like they would be the people to talk to. This lab is going to also look at some sensors, but everything is very preliminary right now.
App बनेको छैन तर you're testing all the.
We are testing the technology
Yeah.
earlier.
The sensors especially, the app especially, not right, so the app would come next. And so that was really kind of our motivation too, because if we, you know, if Dr. Gavin sends some sensors and you test it, the next thing is, and this goes to kind of the engineering question, none of these will work in terms of warnings unless you think about the human beings as well, and so kind of like what they would want.
But going back to your data point, and just like so they could sound like the Ramra like those 35 people. Like I just wonder like where only people who have access to technology, mobile phones, or where only those people asked all these questions.
Yes,
So
yes.
maybe that's the limitation of this
Huge
study.
limitation. Yeah.
Because like somebody like my fupu who is 73 years old, she uses an iPhone.
Yeah.
The app
Absolutely. Yeah.
So I think like there's a lot of digital divide in
Yeah.
Bangladesh.
That's, and I think we
Yeah.
tried to highlight that in ours too. We show kind of one sample, these projects, I cannot speak for Kuna et al. These projects do have some years to go before they come to fruition. And before that time, I think if anything our paper shows, it shows that there needs to be probably an in-person, more representative study towards kind of what people want in terms of that.
Yeah.
Okay, so
So I really forgot the story, but that was in news probably 2 years back. I hope I can get you the news if you want. Actually, some guys or some team were working on that early warning system, like that technology in Nepal, and after a long run of research, they have accomplished that. And I think with the help of ECMOD or like government, that even like practiced that, implemented that maybe 2 years ago, I think. And even they have like responded or like to protect, prevent flood. That was already flood like warning system. And what I got to know after a year that we had a severe flood again, but that was in Kathmandu Valley. But what I saw, and there was a lack that government, like the man said, that government is really ain't working here. So what I want to ask is about this technology, because that is very good and very crucial, and that we need it too. But how do you find the challenges in accordance with government and governmentality, or like the system that is working here? And as you have said and discussed about quality and assurance and all that, so there is a long process, and also since it is neoliberal country, like everybody is like doing like marketing here, like China is here, India is here, so they have the technology, and yet they are not implementing here, and yet they are not doing the thing here. So we have last time in Rosua, the incident that happened in Rosua in Mustang district. So there are a lot of examples. Similarly, even not the government is acting on it, not the private companies are acting on it, while it is crucial. But still, I just want to ask you, in throughout your fieldwork, what are the challenges with like governmentality, local governance, and what are the like acceptance from government? Because we Nepali are busy in our basic life, like operating basic life, basic food, and all that stuff. So that's the thing. Actually.
Sure. You can start. So one of the problems we faced is earthquake early warning technology. We are just in preliminary studies. We are working with students to figure it out. We work a lot with air pollution networks, air quality monitoring networks, because we deployed them starting 2021. We have collected data till 2024, and then now slowly the network is falling out of maintenance because the project ran out, and then the local partner, are saying that they cannot technically maintain it, even though they are like a massive institute. So the problem with most of this project was implemented by them. So all the hurdle we hear is through them, and then on that context, they are a government university institute with government links and stuff. The thing I hear about government from the other side is people who are actually working here in Kathmandu, the other people working on the air pollution research field, and then things they say. One of my friends was telling me that they obtained a couple of sensors, and from the US, it was shipped. It was supposed to arrive here without any import duties. They had proper paperwork, and in the custom office, they just were withheld for 2 months. And then they went there, and then they were we need this, and they're like, you cannot, like, unless they found a person who knew the people there, and like they were telling me that within 20 minutes, after paying 8,000 rupees of like some fees, it was like released. So state at times does not understand these things, and instead of doing the right thing of trying to figure out what it is, which is just 2 Google searches away, like they would create like additional hurdles. And then that has been repeated story from so many different like research partners, collaborators, colleagues working in Kathmandu.
I would say something that I found, I really think more coordination needs to happen, and that's easy to say because we all say it, but I really think that needs to happen. I don't know which news story you found. Was it about earthquake early warning system?
No, early flood.
Flood. That's
Flood.
so interesting. I actually really after this book I want to move to floods.
Yeah.
But it's all hearsay. I did find one Nepali Times article, I think, but supposedly some China-backed projects came in after the 2015 earthquake and also implemented sensors for the earthquake, and somehow that has just not been maintained, or I can't quite figure out. And it's so interesting the way we have to go about even trying to find these is really just asking people, and not even to put the blame on the government agencies or the NGOs like INSET, but really just because of the lack of coordination, maybe because of like just under-resourced, including in time. Yeah, there just is not, you spend so much time even trying to figure out what's happening. That doesn't really answer your question at all, but that's the experience, yeah.
Yes, please.
I'm more curious about the technical aspect of the early warning system. Like, how does it detect the earthquake, or it deploy information on the apps and the epicenter where the wave is just generated and it is not transferred from one location to another?
This, do you want to answer? You probably know more.
Yes.
This goes with the networks as well, so actually very similar to his answer.
Yeah, it relies on like the idea of networks too. You deploy a series of these. So basically a sensor that detects motions in like 3 different dimensions, right? Like this moment or this moment and that moment, and you have a lot of data coming in. And then the moment it detects even a tiny like movement, like it is just continuously monitoring all this movement. And if in a series of this location you detect a very similar pattern, like something is detected, then it might be a very small earthquake, like an insignificant earthquake. Something is detected. And then since it is continuously monitoring this thing, we are actively looking for the first kind of wave for any like earthquake that travels very fast. It has a very distinct feature. And based on that feature, we'll have something for which Sabita worked a lot. She's sitting there. And then based on these features, we can like probably with certain amount of confidence say, is this a P wave or a S wave? And if it is a P wave, what kind of P wave it is, and what's probably going to be the magnitude of coming S wave. And then there is the predictive element there. And then 100% time it's not going to be right, but it's going to be fairly accurate most of the time. And that is how we detect, a major S wave is coming that might cause a lot of disruption, and then boom. And then based on the threshold and decision we set, like we can be like, let's issue a warning, or even if we detect, like say a 4 magnitude earthquake, it's not significant enough and let's not detect any warning. So that is the predictive component. But the main thing is we need to detect that first wave before that like massive magnitude coming. We cannot say out of blue that, based on like all the other meteorological or other thing, we can detect an earthquake. We need that physical moment, the primary P wave, to be absolutely certain on these warning systems.
Yeah, and this is why there's several years of testing sensors as well. And so not only is it the technology, but it's also like making of like the algorithms or like just how these things work. And different sensors can work in different ways as well.
Yeah. And different location can vary in a different way because the features that you get, like our like bedrocks might be different, these things might be different. So a technology that is like ready-made for Japan cannot be identically copied to Nepal. We need to have some local understanding and local reasons for that.
Shweta?
तपाईँले आन्सर अलिकति गर्नुभयो यस्तो वार्निङ सिस्टम चाहिँ अरू कुन कुन देशमा चाहिँ अलरेडी इम्प्लिमेन्टेड छ र त्यसबाट के सिक्न सकिन्छ हामीले
क्यालिफोर्नियामा छ लाइक अ भेरी गुड मेक्सिकोमा छ जापान इज द पायोनियर
Yeah, I think a lot of this stuff comes out of California and Japan. New Zealand, they have had a lot of research coming out there because I think they are creating. I don't know if it's actually done or not. And then Switzerland. There's some other places as well, but there are several countries kind of looking at it, and that's how I would describe Nepal because there are kind of homegrown institutions that are kind of looking at it, like some students at IOE, and then there seems to be some of these other projects going on as well.
I don't know how old you are now, but after the political change of 1990, one of the first social movements in Kathmandu was about air pollution.
Oh, I didn't know that.
Safa Temple movement
So-
also popped in.
Yeah, and a lot of that work actually happened at this institution, right?
Wow.
Hey.
So if you look up Safa Temple advocacy, that work was done by people, one of whom still works for Chautari.
Yeah,
So that was 98 onwards.
yeah,
But I'm referring to even earlier.
yeah.
I could even say this will be journalism advocacy against air pollution. So if you go to the room behind this room and look up the Kantipur archives, you will find lots of reports about air pollution. So the question I'm asking is, when a data scientist turned into an engineer who's thinking about air pollution
and community
and community,
Who wanted to study religion?
Who wanted to study religion?
and worries about networks and thinks about the budget needed for the kinds of networks you need to actually do monitoring at a hyper local scale.
Yeah,
If you then think about the capacity that has been developed in Nepal to do the kind of work that you are interested in intellectually as of now, over the last 35 years, what kinds of thoughts go through your mind? I know what data science is, right?
Yes.
I'm not a data scientist, but I took 9 courses in mathematics when I was an undergraduate, right? So I went to graduate school in economics,
Yeah.
not based on what I did as an economics as an undergraduate, but just when UPenn looked at my transcript and said, this guy has taken 9 courses in math, he can deal with the math. But I walked out of that department, and became a historian, and began to have a different understanding of Nepali society in this new discipline. So what I'm asking you is, you want to, I can get the sense of you want to make things work in Nepal. You mula central system esto chahiyo bhane ta esto garna payen usto garna payen. But then you've already given us the example of this 2 महिनासम्म कस्टममा आएर अड्केको संयन्त्र संयन्त्र.
yes.
So how do you deal with this in a daily way intellectually?
Yes.
मेरो कुरा बुझ्नु भयो?
हजुर. सो यसमा चाहिँ मलाई इन्ट्रेस्ट पनि कसरी आयो भन्ने कुरा चाहिँ नि यो सबै फिल्डमा मैले चाहिँ क्याम्पसमा चाहिँ अन क्याम्पस पनि एउटा काम खोज्नु पर्ने बेला चाहिँ म त्यतिखेर चाहिँ रिलिजियस स्टडिज डिजिटल ह्युम्यानिटिजमा इन्ट्रेस्टेड थिएँ. डेटा साइन्स र डिजिटल ह्युम्यानिटिज मेरो थिसिस अन्डरग्रेजुएट थिसिस पनि डिजिटल ह्युम्यानिटिजमै थियो. अनि यता मेरो प्रोफेसर जो अहिलेको मेरो करेन्ट ल्याब छ पिएचडीको त्यहाँ चाहिँ नेपालमा प्रोजेक्ट गरिराख्नु भएको रहेछ. अनि नेपालको कन्टेक्स्ट बुझ्ने मान्छेलाई चाहिँ समरहरूमा चाहिँ यहाँ रिसर्च गर्न पठाउनु भयो. अनि त्यहाँ हेर्ने बेला चाहिँ संयन्त्र खराब त छ धेरै ठाउँमा, तर संयन्त्रले कसरी काम गर्छ पनि देखिरहेछ कि. जस्तै त्यो कस्टममा रोकियो तर हाम्रो 70वटा सेन्सर कहिले पनि रोकिएन, किनभनेपछि हामीले चाहिँ अब नेपालकै टियुमा पनि सिडिएसलाई समातिसकेपछि उहाँहरूको सबै चिनजान सबै कुराहरू छ. त्यसैले वी हेभ टु बी रियली केयरफुल अबाउट हु इज आवर लोकल पार्टनर. अब त्यसकै अर्कोमा अर्थक्वेक सिस्टममा वी टुक फुल चोक. अनि किनभनेपछि नेपालकै सिस्टममा उहाँको सरहरू सबैले बुझिसक्नु भएको छ. अनि त्यही भएर चाहिँ वी क्यान बाइपास हुन्छ नि, त्यहाँबाट आएर बाहिरबाट आएर चाहिँ यो सिस्टमले काम गरेन भन्ने जो फ्रस्ट्रेसन हुन्छ त्यसलाई बाइपास गर्न वी हेभ टु फाइन्ड अ रियली प्यासनेट लोकल पर्सन. लोकल्ली प्यासनेट अहिले चाहिँ हुन्छ नि लोकल्ली काम गरिरहेको. अर्को चाहिँ जस्तै म यहाँ योपालि आइसकेपछि आइ एम लाइक मिटिङ सिरिज पिपल. यो चाहिँ यो वायु दृष्टि भनेर एकजना हाम्रो सक्रिय पाण्डे भन्ने भाइले चाहिँ यो आफ्नै स्टार्टअप अनि त्यो सेन्सरहरू टेस्टिङ गरिरहेको छ. पर्फर्मेन्स लुक्स रियली गुड बेस्ड अन द डेटा दे सेड. अनि देयर आर पिपल हु आर लोकली वर्किङ. अनि जहिले चाहिँ अब नयाँ प्रोजेक्ट यदि मैले लन्च गरेँ भने मलाई चाहिँ के लागिरहेको छ भनेपछि यो मोनिटरिङको केपेबिलिटी चाहिँ जति गर्न सकिन्छ अनि फ्रस्ट्रेसन छ तर एकजना अथवा दुईजनाले चाहिँ त्यो फ्रस्ट्रेसन चिरेर निस्क्यो भने अलिकति दुःख गर्यो भने जस्तो मैले चाहिँ समरमा गएर कुनै टेक कम्पनीमा इन्टर्नसिप गर्नुको सट्टा 3 महिना नेपालमा बसेर 2-3 वर्ष रेगुलर खटेर अनि सिरिज अफ लक अरु फ्याक्टरको कारणले चाहिँ ड्युकमा चाहिँ अहिले ग्लोबल जो एक्सपोर्ट हुन्छ यो लो कस्ट सेन्सर एयर पोल्युसनको हामीहरु सुपरभाइजर अथवा 2-3 वटा इमेल लेख्न मिल्ने ठाउँमा अनि मलाई चाहिँ फ्रस्ट्रेसन के हुन्छ पुरै थाहा छ म सुरुमा चाहिँ नेपालमा 2 वर्ष ग्याप इयर लिएर जानुभन्दा अगाडि चाहिँ म नेपाल फर्किनमा अब त पढ्न गइयो अब फर्किनु भनेपछि 6 महिनामै फर्केको थिएँ अनि मलाई चाहिँ दुःख छ भन्ने थाहा पाएर पनि दुःख खट्न सकेर गयो भने चाहिँ आई स्टिल फिल कि यसको सम्भाव्यता छ किनभने चाहिँ वी आर नट इन्भेन्टिङ लो कस्ट सेन्सर टेक्नोलोजी के 50,000 मा सेन्सर किन्न मिल्छ हामीले 50,000 को 100 वटा सेन्सर 50 लाख मा किन्न मिल्छ व्हिच साउन्ड्स लाइक अ ह्युज मनी तर काठमाडौँ महानगरपालिकाकै वातावरण बजेट होला के त्यो भन्दा बढी हुन्छ नि उनीहरुले उठाउने वातावरण करदेखि बजेट छैन भन्ने होइन बजेटको मिसम्यानेजमेन्ट छ त्यो पनि थाहा छ तर अब लकको फ्याक्टरले कस्तो छ भने यस्तो ठाउँमा छौं कि यदि त्यो 50 लाख कै होस् 1 करोड होस् 2 करोड होस् उहाँहरु दिदीहरु जस्तो मान्छेसित एक्सेस छ सो हुन्छ नि रिपिटेडली वी क्यान फाइन्ड अ वे टु पुश थ्रु दिस अर्ली 3 इयर फेज मलाई चाहिँ सबभन्दा लाको डर चाहिँ पहिला पनि हामीले 3 वर्ष नेटवर्क चलायौं अहिले नेटवर्कको अत्तो पत्तो छैन त्यसैले चाहिँ जस्तै पुल्चोक बेस्ड कुनै इन्स्टिट्युटले चाहिँ त्यो पुरै नलेज सिस्टम क्यारी गर्यो भने अनि वी हैव अ सेल्फ सस्टेनिङ साइकल जस्तो चाहे त्यो लोकल एन्टरप्रेन्योरहरुलाई त्यसमा लुप इन गरेर होस् हु क्यान रिपेयर दिस सेन्सर और म्यानुफ्याक्चर दिस लाइक किनभने दिस सेन्सर इज भेरी चिप के 6000 को सेन्सर हो खास नाप्ने चाहिँ तर त्यसको केसिङ त्यसको फ्लर टेक्नोलोजी गरेर 50,000 पर्छ हुन्छ नि अनि त्यो सबै गर्न सक्ने चाहिँ नलेज बेस यहाँ बिल्ड होस् भन्ने चाहिँ त्यो मेरो चाहिँ मनभित्रको मेरो पर्सनल इच्छा चाहिँ आकांक्षा चाहिँ त्यो हो
Shana, did you just say that you have access to lots of money?
No. I'm saying a person who can help me find access to lots of money. Hopefully.
I don't know where you get that. It's just, so this question though, I feel like also it's the optimism that is driving, which is, you're very optimistic. Yeah. I think one thing about the institutions, and this is the thing, even working with IOE is, you know, the students graduated, go abroad. Yeah. So yeah, I think time will tell whether the institutions can be created that can actually,
So let's do the last question.
So I'm going to bring back the pessimism and last time. Right?
Because I study political science, so I'm pessimistic.
So, but you had stressed, and it's the same kind of question that Protas asked last. You had stressed that now we need coordination, right? If we had better coordination, then these things will work. But coordination is key, and we know from, and I will now presume that you're writing your book on the earthquake, blah blah blah, that the issue of coordination was clear. It's tragic. It was tragic. Donors were as tragic as the state was tragic. Blah blah blah, and the whole thing. So, given that our recent history has been so tragic in terms of coordination, and our whole governance structure is tragic in other aspects, right? How optimistic are you that this thing will then be? Because we know how the structure works. We know how the system works. We know all of these things, and coordination, it's not just the state. Donors are as
and universities and partners like me.
They're more than, in fact, donors are probably more dysfunctional. The federalism group hasn't met for ages in UAE, right? And so you're like, so if you any hope opposite the state, maybe the donors can help. That's not going to happen either, right? So
Understood.
No, so where's the optimism? So where's the optimism? Give us some optimism.
You should ask Raj for the optimism. I'm not sure. I honestly don't know. Yeah, you're also asking an American whose own country is kind of having some weird stuff going on.
We're not getting there.
I think this I think was a good first wave. We also, that's why we did it on Facebook, because it's very non-invasive. We wanted to start looking at it. I don't know if I personally, like as a social scientist ethically, would kind of push more on this until I knew where the projects were right now. And I actually have tried to email some people, and it actually is very difficult to kind of know. And I know that there are some efforts, you know, by students even in this room who are looking at some things there too. I wouldn't say I'm like super pessimistic. I think we should just wait to see, because you can't expect the institutions that exist to do more than they can. I really do think, and this actually goes to Schroeder's dissertation, when the institutions are weak, for some reason, it really kind of relies on individuals to kind of push things through. And so maybe some individuals can actually make something. Maybe this IOE lab kind of becomes more, you know, like robust or something like that. I'm really not answering your question. I'm skirting it. But yeah, I don't know, maybe, yeah.
राजको के थप्नु छ लास्टमा
लास्टमा जस्तै यसमा चाहिँ म युजली चाहिँ खास टेक्नो पेसिमिस्ट नै हो जुन पर्टिकुलर यो एआई टेक्नोलोजीदेखि लिएर यताउति तर कुनै कुनै चाहिँ यो मेजरमेन्टदेखि लिएर यो मोनिटरिङको सिस्टममा चाहिँ एकदम इन्ट्रेस्टिङ डेभलपमेन्टहरू हुन्छ कि जस्तै 2014 मा एउटा पेपर आएको थियो इन्डियामा चाहिँ यो इन्भाइरोमेन्टल पोलिसीमा यति धेरै ल छ एयर पोल्युट गर्न पाइन्न वाटर पोल्युट गर्न पाइन्न तर पनि पोल्युसन केही पनि रोकेको छैन किनभने त्यो इन्टायर सिस्टम चाहिँ ट्रुथ टेलिङ बेसिसमा बसेको थियो यु हेभ टु रिपोर्ट अनि उनीहरूको चाहिँ त्यो कन्टिन्युस मोनिटरिङ सिस्टम थिएन अनि जम्प ब्याक टु 2021 अनि गुजरातको स्टेटमा चाहिँ त्यो सबै फ्याक्ट्रिजहरूमा उनीहरूले चाहिँ त्यो कन्टिन्युस मोनिटरिङ सिस्टम राख्यो अनि पिएमसी राख्यो अनि एउटा चाहिँ मार्केट बेस्ड सिस्टम इन्ट्रोड्युस गर्यो पर्टिकुलेट म्याटरमा चाहिँ पहिलोचोटि वर्ल्डमै पहिलोचोटि चाहिँ स्टेट अफ गुजरातमा सुरतमा लन्च भयो पछि दे एक्सपान्डेड इट टु अहमदाबाद अनि 2025 मा अस्ति भर्खरै 4 महिना अगाडि बल्ल पहिलो पेपर आयो कस्ट बेनिफिट एनालिसिस गरेर अनि त्यसले देखाइरहेको छ कि 24% सम्म इमिसन कन्ट्रोलमा उल्टो हेल्प गरेको छ पर्टिकुलर म्याटरको सो कुनै कुनै टेक्नोलोजीहरू चाहिँ यसरी आइरहेछ कि इभन अन अ विक स्टेट किनभने त्यो अन्डरस्ट्यान्डिङ चाहिँ के थियो भने कमजोर स्टेटले मोनिटरिङ गर्न सक्दैन तर होपफुली देयर आर सम टेक्नोलोजी नट अल टेक्नोलोजी इन लार्ज आई एम स्लाइटली टेक्नो पेसिमिस्ट तर कुनै यो चाहिँ इट्स much simpler than like particularly monitoring technology and its costs are much more doable even in a weak state or I don't want to say failed state that I'm saying in a weak state ma pani I think we can use certain of this technology in certain domains sabai ma ta kaam gardaina but in my field I'm like hopeful because the technology is getting very cheap there is existing literature and knowledge base that we can just import we don't have to invent anything हुन्छ नि कोही काम गरेको कुरालाई अलिकति मोडिफाई गरेर we can just like get it done we have enough resources like यदि if somebody gives like few good people and like हुन्छ नि say a decent amount of money this can be up and running within 3 years that is just हुन्छ नि it's a slow onset problem that is not too sexy and that makes
3 years so when you graduate, we have it on, we'll write it down.
Hopefully, that will
we'll come back here and see.
Hopefully, that is the thing that will bring me back here.
Okay. So it's about 4:32 कति भयो सना र राज दुवैजनालाई धन्यवाद for giving
Thank you so much.
stuff to think about. I hope both of them come back repeatedly.
Yes.
Again and again to talk about other stuff, other research presentations. I should have pointed out to people who are here for the first time that the earliest discussions or what we call because it happened on a Mangalbar, that series was eventually called Mangalbar. Started in October of 1991. So in October of this year, that series, the Mangalbar series, completed 34 years, and it's been going on for all those years because specific individuals during all those years have become, in my words, the donkey carrying those discussions and doing the real grunt work. Groundwork to actually take those discussions around. And so hopefully that's a story to remember when on the bad days. But all of you, please come back again and again. Thank you.